Lesson 91 has two parts. The first part is on the multiplicative property of inequality, and the second part is on spheres. Now in Lesson 64 we talked about the additive property of inequality, and you remember if we had an equation like this, x plus 5 is less than 7, we want to simplify that to just get x by itself. We work on it just like it had an equal sign instead of a less than sign, and we add a negative 5 to both sides, and we end up with x less than 2. The multiplicative property of inequality works pretty much the same way. For example, if we had this inequality, 2x is greater than 8, we would divide both sides by 2, just like it was an equal sign in between them, and we end up with x greater than 4. The difference between the multiplicative property of equality and inequality comes when you have a negative coefficient for x. Look at this. If I had negative 2x is greater than 8, this is different. We can divide both sides by negative 2, and we have x greater than negative 4. But that's not true. What we're saying there is if negative 2x is going to be greater than 8, then x has to be greater than negative 4. So greater than negative 4 would be like a negative 3 or a negative 2. And just think about that. That doesn't work. If we had negative 2 times a negative 2, that would give us a positive 4. That is not greater than 8. It's less than 8. So what you have to do when you have a negative coefficient in front of your x value, you divide both sides by that negative coefficient. You have to reverse the sign. So now you have to make it x, not the sign, but the inequality. You have to make it x less than negative 4. That works. So when you have a negative coefficient for x and you divide both sides by that negative coefficient, reverse the inequality when you do that. The best way to understand that is to use the additive property to figure that out. So let's just rewrite that. Negative 2x is greater than 8. And let's make that negative 2x positive by using the addition rule. We'll move it over, the whole thing, over to the right side. And so now we have 0 is greater than 8 plus 2x. Subtract 8 from both sides. We have a negative 8 is greater than 2x. Divide both sides by 2 and you get negative 4 is greater than x. And if you read that from left to right, it's x, or from right to left, you would say x less than negative 4. So that's how that works. You can understand why you have to reverse the sign when you divide both sides by a negative number, why you have to reverse that inequality if you look at doing it the addition rule way. So what I have written in red there is something to think about when you use the multiplicative property of inequality. If you divide by a negative or if you multiply by a negative, either way, you have to reverse the inequality. I just showed you why that works by using the addition rule. And you can just look at the steps that were involved there. It takes a lot fewer steps to use the division rule just to divide both sides by a negative number and reverse the inequality rather than doing the addition rule every time. So it is kind of a shortcut to divide by a negative number and reverse the inequality. You know why that works though, why you have to reverse the inequality now though. And I think that's real important to know why these different operations work the way they do instead of just doing a shortcut for the sake of doing it. Let's go ahead and do some practice problems. I want you to graph this relationship on a number line. So you have negative x is less than or equal to 3. Well, let's get rid of that negative in front of it. That's always what we want to do on an inequality problem, is to get the x by itself, just like if it was an equation. And so we'll say x greater than or equal to, we move that negative over, multiply or divide both sides by negative 1, so we have to reverse the equality, and we end up with greater than or equal to - 3. So let's go ahead and draw a number line. Now be thinking about greater than or equal to -3. That means smaller absolute values than the 3. So -2 is to the right. That means it's greater than -3. So we're going to the right of -3. We're including -3 though because it says greater than or equal to. So we put a dot there, and the domain is integers. So we just put dots. We don't shade everything in. -2, -1, 0, 1. Shade the arrow in to show that we're continuing on to the right. Let's do one more. 3x plus 5 is not less than 8. So that means it's greater than or equal to 8. So let's just add a -5 to both sides to try to get the x by itself. So then we'll have 3x is greater than or equal to 3. And then we'll use our division rule, divide both sides by 3, and we'd have x greater than or equal to a +1. Let's go ahead and graph this on a number line. And so we are working with a 1 there. We're working with greater than or equal to 1 and a domain of real numbers. So since it's equal to 1, we shade in, we put a closed circle at 1, and we shade to the right to represent greater than or equal to, and then we shade the arrow in as well. So on the multiplicative property of an inequality, if you have to multiply or divide both sides by a negative number, you need to remember to reverse the sign around, or reverse the inequality around. Part B of this lesson is on spheres, and in this lesson they're going to tell you a couple of formulas for the volume and the surface area of a sphere. Now the formula I like to use for the volume of a sphere is just this one, 4/3 pi times the radius cubed. Now they have a definition in the book about the volume of a sphere equaling 2/3 the volume of a cylinder into which that sphere fits. You can remember that if you want to, if you're better at remembering things like that, but I think it's better just to have a formula, 4/3 pi r cubed. The area of a circle, that's the next closest thing to a sphere, that's equal to pi r squared. The volume is 4/3 pi r cubed. And then the surface area, we can just say SA, that's equal to 4 times pi times the radius squared. The area of a circle is pi r squared, so it just happens that the area of a spherical shape, if you added the area of just a circle 4 times, that would be the surface area for a sphere. So just try to remember those two formulas. You don't use them very much, so they are a little bit difficult to try to remember. I think it's okay on a test if you need to go back and look up the formula. It's not a bad thing to do. The most important thing is that you know how to apply the formula, not that you have it memorized. I mean, engineers, they have all kinds of formulas that they work with. They don't have all of those memorized. They go back to a book. The most important thing for them is how to apply it. If they can't apply it correctly, then that's worthless to them. It'll just save you some time if you memorize them, but I don't think that's a mandatory thing to do, especially on ones that you don't use very frequently. So let's do a practice problem. If you had a sphere with a radius of 3 inches, I want you to find the volume and the surface area for that sphere. Well, the volume, that would just be equal to 4/3 times pi times 3 cubed. And so that's going to be 4/3 times pi times 9. And so you can just get your calculator out to solve this, and you could do 4 divided by 3 first and figure out that, then multiply by 3.14, which is pi, and then multiply by, and actually I did that wrong, didn't I? 3 cubed is not 9, it's 27. So we should have 4/3 times pi times 27, and that equals 113.04. And so that is in cubic inches, right? And that's an important thing to put on there. Inches cubed. 113.04 inches cubed. The surface area, we'll just say SA for surface area, that is equal to 4 times pi times 3 squared. So this time 3 squared, that will equal 9. And we'll have 4 times pi times 9, or just 36 pi. And so we can do that on our calculator. 36 times 3.14, and that's equal to 113.04 again. So the number is not the most important thing, though, right? That doesn't mean that those are equal things. They're totally different things. One of them is volume, one of them is surface area. 113.04 inches squared. So that's the answer there. If you don't understand the difference between those two things, it doesn't matter if you have the formulas memorized or not. Hopefully by now you know the difference between volume and area. And so that's not a big deal to you, and that's not confusing to you. Even though those numbers are the same, they're describing totally different things. One of them is volume and one of them is area. So you can memorize those two formulas if you want. It'll just make your math easier later because you won't have to be looking them up. But I don't think that's a mandatory thing, especially on formulas like that you don't use very much. Now the area of a circle, you should have that memorized because you use that all the time. Area of a triangle, things like that. Okay, well that's all for lesson 91.